So, here we are again on In the Moment. This is Lee, and today we're going to continue talking about alignment. But this time we're going to stay a little closer to home, and we're going to talk about alignment within cells. Anyone who studies molecular biology will quickly realize that the complexities of molecular biology are insane. In each of the trillions of cells in your body, right at this very instant, each second, in every single cell, there are trillions of different operations being performed by hundreds and hundreds of billions of molecules every second. There's so much activity in one cell in 1 second that if you added up all the computing power of all the computers on Earth right now, it wouldn't even come close to what's necessary for the information transfer that takes place in a cell between protein molecules in a single second. It's insanely complex, it's insanely orchestrated, and in fact, one of the reasons people started working on artificial intelligence was that in the medical field, they realized no one was ever going to understand what actually takes place in a single cell from the point of view of molecular interaction without something that was smarter than a human being in certain ways to analyze it for us. So let's just talk about some of the molecules in the cell, and let's talk about the ones that regulate energy. Those are called mitochondria. And the weird thing about mitochondria is that the mitochondria in every cell are little energy factories. They're little vesicles that produce the energy for the cell, and they all come from your mother's side of the family, because the sperm don't have a little energy molecule in them. All they've got is their head and the DNA, and that's about it. A cell has a whole factory of energy in its mitochondria, and those are inherited from the mother's line because they're always in the egg. It is, by the way, widely presumed that mitochondria were once an independent living organism that entered the cytoplasm of a cell with a nucleus and supported its operation. So, in a weird way, it's kind of a second organism inside the cell's organism. So, mitochondria produce energy, and they produce energy by lining up molecules and exchanging electrons. Okay. We won't get into the electron thing too deeply just now, except to say that if the tissues inside the mitochondria, the complex protein structures that produce the energy, aren't properly lined up in the right kinds of little lines, the energy they produce is inferior. And that means that alignment is critical to the amount of energy that each cell produces in you. And you would think to yourself, oh, well, they're always lined up. That ain't the case, folks. There are whole classes of disease where your mitochondria don't line up properly. It's even involved in dread diseases such as ALS. And I call it a dread disease because I've seen people die of it. So you really, really need your mitochondria to line up beautifully well. And often they don't. What contributes to good alignment in the case of the mitochondria is probably sound nutritional practice, exercise, and all the things you usually think contribute to health. I'm bringing them up simply so that you understand that alignment inside cells is vital to your energetic processes. And this affects your ability to see, to hear, and to have sensation. So, Let's talk about the electrons a little more. Electrons are weird little things. They circulate atoms, which are 99.9% empty space. Actually, there's far less solid stuff in there than that, but never mind. And electrons, it's been discovered, move at close to the speed of light across chains of proteins. That is to say that when the mitochondria are exchanging electrons in their activities with one another, the electron surfs across the surface of molecules. What does that mean?